I'm here to answer some questions about myself, not the other one. I'll do some Shakespeare if you want.
Who would win in a fight, you or other Brian Coles?
Oh, I don't know, he's pretty solid. He's a, so I think it'd be a close run thing. In some ways, there's a very easy answer, which is Carl Sagan was a huge influence on me. So he made his series Cosmos. And at the time, there wasn't a great deal of science on television. It confirmed my love of astronomy. Sagan always tried to explain why exploring nature and exploring the universe in all its sort of esoteric detail is useful, and not only useful but necessary, and one of the foundations of our civilization. And so connecting astronomy and physics with culture and civilization itself was, to me, sort of game changing, and I never forgot it, and there was never any other path I was going to take after watching that. I'm not even going here, right? I'm not even. If I could refilm, the question was if I could refilm the moon landing. There's some assumption here, isn't there? There's a trap in this. The moon landing was not filmed in a studio. It was filmed on the moon, right? Because it was actually cheaper to do that than it was to fake it at the time. And I've met several people who walked on the moon. I've been very lucky, and quite a few people who flew around it. Yeah, I think it was done right the first time, filmed on location, and I don't think we need to redo it. But what was the question? Who would direct it? I think, well, Chris Nolan, I would ask to direct it because he would film it on location. so he'd go there and film it. So I think Christopher Nolan, without a doubt. What 3 people, living or dead, would I invite to a dinner party? That is so difficult, isn't it? I mean, there are so many people. I suppose with some obvious answers. I mean, it's honestly true that I would have loved to meet Einstein. Einstein thought about physics and thought about science in a unique, I would say unique and tremendously sort of romantic and deep way. But it would be lovely to sort of get a few drinks in him and find out, really dig down into that, his philosophy of physics. I'd tell you, I would have loved to meet David Bowie, and I never did. And it's one of my great regrets that I never spoke to him and met him. I'd invite Luca, the last universal common ancestor. So I'd have this jar at the dinner party of stuff. This population of single-celled organisms just sat there at the head of the table. Like, I've been wrong about almost everything. I genuinely believe that one of the key skills you develop as a research scientist is to enjoy being wrong. And the reason is that if you're interested in the way that nature works, if that's all you want to know about, then being wrong is a necessary part of that process. The thing to say is that we're never right in an absolute sense. So we don't have the laws of nature, as we call them, that we think are absolutely fundamentally correct. Given that you're never absolutely right, which is a key thing that you have to learn, the fact that you can be wrong often, you are wrong often, narrows down the list of possibilities. So if you're not interested in showing off or showing people how clever you are and all that, which is not what you should be doing as a scientist, then you're delighted when you're wrong, because you can rule some stuff out and you understand a bit more about nature. So I've been doing a bit of work on black holes, and I got very interested in black holes. We're pretty sure, actually, I'd say we are as sure as we can be, that if something falls into a black hole, then ultimately in some form it comes out again in the far future. But by that I mean in the same sense that if you take a book and set it on fire, right, burn a book, then if you could, in principle, collect everything, all the ashes and the light and everything that comes off the book, then in principle you could reconstruct it. And it seems, we're pretty sure it's the same for black holes. You throw the book into a black hole, from the perspective of the book, we think you'd fall across the horizon into the interior of the black hole and go to the end of time, basically. The book essentially goes to this thing, the singularity at the end of time. From the external perspective, we think that the book gets vaporized on the horizon, and we think that both pictures are correct. But either way, they're different views of the same physics. The information that's contained in the book comes out in the Hawking radiation in the far future. So that's awe-inspiring, because it's telling us about the nature of space and time. And the awe-inspiring thing is we're beginning to suspect that space and time are not fundamental properties of the universe, but they're made of something else. So we're talking about building blocks of space and time. So that's awe-inspiring, the fact that time might be made of something. That's an interesting question. I mean, because the songs that most people know that I've been involved in are from D-Ream, right? The band D-Ream, which is a band that I was in kind of briefly, really, in a way, in the early to mid '90s. Although we did Glastonbury this year together, and I played Things Only Get Better, which is a great song. And it's great to be a small part of something that is now part of cultural history, and that song is certainly part of our history now. But I was in a band before that called Dare, which was a rock band that I was in for 5 years, or from the age of 18 to 23. My memories of being in a band come from that rock band, actually. And so some of those songs I loved being a part of. So there's an album, I think it's a great album, actually. I'm going to say it's a great album. I love the album. It's called Out of the Silence, and it makes an appearance in Solar System. In a sense, the universe behaves like a quantum computer. If you're playing a computer game, then there's kind of a reality there, right? But it emerges from just bits of information. We think that in some sense, and I keep saying in some sense because we don't have the language, but there's a sort of a network of bits, qubits, quantum bits, and that may be a description of the world, including ourselves and space and time. And this kind of emerges out of this network, which looks a bit like a quantum computer. That's not to say, and you can't edit it there, that is not to say that I'm saying we live in a simulation. I am not saying we live in a simulation. I'm saying it looks a bit like the universe has a description which is similar in a sense to a quantum computer. But all those weird little caveats are necessary if this is on Instagram or somewhere for it not to go mad. All those little caveats are necessary parts of this discussion.
So what are you not saying?
So what I'm not saying is that we have evidence.